we are on. It always takes a sec to connect. All right, here we are. All right, welcome back everyone to Ask a Scientist with the Asheville Museum of Science. My name is Abby and today we're going to be talking about chemical engineering with Alex Cardile. Or is that, how do you say your last name?
Cardile.
Cardile, okay. So we're really excited. It's going to be really funny today. We're going to be talking about explosions and all sorts of really cool stuff. So I'm just going to pass it off to Alex and you can all feel free to send in your questions and we will get them all answered.
All right. Hey, everyone. My name is Alex Cardile. I studied at Lehigh University and got my BS in chemical engineering back in 2015. Since then, I've been working as an engineering consultant for a property insurance company, basically to prevent them from blowing themselves up and burning themselves down. And today, the main thing I'm going to talk about is dust explosions. And so I'll get right to it. You feel free again, like Abby said, just chime in with any questions as we go along. Here we go. Share screen. All right, large dust losses. So here's the basics of a dust exposure. I know for the most part, when you see a pile of dust, you don't think, wow, that looks like it can explode. I'm just going to start by going over the basics of a fire. Obviously, when you make a campfire, there's some many basic techniques with TP, lean-to, log cabin, and star. Never seen a star before this, but basically, as you can see in every single one of them, it starts by burning the smaller stuff first, so then you can get the larger stuff on fire. And then as you can see on the right, once it kind of gets going, you're good to go. So yeah, dust basically is just very, very small stuff. It burns extremely easily because it's very tiny. If you think about it, it's a lot easier. If you hold a match to a log, it's not necessarily going to light. Hold to a twig, it's going to light pretty quickly. And if, the smaller you go, easier for it to light, and the faster it's going to burn. It's the base of a dust exposure. Now we have fire, but why is a dust fire so bad? Again, like I said, it burns very easily, but three conditions are needed for there to be for it to be an issue. Like for example, the dust needs to be combustible. You can't burn something like sand. Obviously, if it comes from a rock, it doesn't burn. It's actually a really good general rule of thumb. Oxidized metals, rust is not going to burn, anything like that. Metal dust, except for specific kinds, don't really burn. But for example, wood will, sugar will, and we'll get to that later. Anything that's organic will burn pretty quickly. And if you want to have a dust explosion, the space has to be confined. For example, if you burn something out in the open, the heat's got a lot of places to go. So you're not necessarily going to see a pressure buildup. You're not going to have necessarily a large explosion. Third, the environment must be conducive for there to be a fire. So there must be oxygen. I'll kind of go into that a little later on, but say you had an inert environment, say you had no presence of oxygen, you can't burn, you can't possibly have a dust exposure. Properties of combustible dust, all about composition and particle size. For example, like I talked about before, the composition, is it an organic material? Is it not? As you can see here, this is a really fine powder, pretty large amounts. As you can see too, it's also suspending into the air. That's where particle size comes in, because say you got wood chips. Wood chips aren't necessarily big, but they're not just going to disperse in the air and stay there. Whereas in this situation, you have that fine powder, you can kind of see it dispersing into the air. And again, we'll kind of talk about that later on and how that can create an explosible environment. Confined spaces. Basically, if you have a confined space and the heat has nowhere to go, that's when you have a problem. Think of like a balloon. If you were to put a match up to a balloon, the air is going to expand. It's going to have nowhere to go. Balloon pops. Same kind of thing happens with a dust explosion, except when you have it happen on a commercial scale, it's often a metal box, and the results are a bit more dire. The one thing I would like to mention at this point in time is that while on this, you're going to see some pretty big explosions today. This isn't necessarily something you're going to see at home. You know, in your dad's wood shop, you're not going to see some of the dust particles flying around. That's not going to cause a big problem because there's just not enough of it there. We're looking here at like a factory level. This is going to be some very, very large scale. It's a very large scale, and this is what I look at on a daily basis in my job. The one thing too I mentioned before, combustible atmosphere. Here's a basic combustion reaction. This is basically how wood burns, honestly, because the end up happening is you have an organic material, which is made up of carbon and hydrogen molecules of sorts in some combination. You have oxygen. And at this point, you have some sort of heat source that causes the things to burn. And then you have two products, carbon dioxide and water. So basically, you need to have carbon, hydrogen, and oxygen to create these two products. And that's why this needs to be in the environment for this to happen. And then when this happens, when you get to this end too, there's also, it's not shown on this chemical formula here, you also have a release of energy to get from here to here. And that's where the problem comes into play for a dust exposure. And so now I'm going to show you one or two, this is one more fun part. I'm going to show you a couple of explosions on a large scale. I'll show you the smaller scale one first. Give me 1 second. We'll stop share. Let's go to, oh boy. Here we have a dust silo that's starting to kind of break down. Let's see. I'll kind of skip towards the front a little bit. As you can see, there's some grain kind of falling out the sides here. We haven't quite gotten to the point where they, as you can see here, this is confined inside of there. But grain has a lot of carbon and hydrogen in it. It's a very small particle. And once this, eventually in this video, you're going to see it get released. And then because it's going to hit a bunch of stuff, it's going to grab an ignition source. And then you're going to see an explosion occur out in the open area. And again, this is a very, very large amount of grain. There's a truck for scale. This is a huge amount of grain. This is not something you're going to see in your house. But once this thing falls over, the fun happens. And again, these people are way too close to this. This is really not, if you do something like this, run. This is really not safe for the air. Up here, some of the grain kind of coming out the sides here. Here's the fun part. And as you can see, when you have a huge amount of grain like that, or a huge amount of dust, that basically was like an action movie explosion. It can get pretty nasty pretty quickly. So let's see, I'm gonna show you one more thing. Let's grab this one real quick. Give me 1 moment while I get this thing to load up. Oh. Wrong one.
When there's that much dust, where does it get the heat source to start the explosion?
That actually is friction, because all the stuff's rubbing together and you have so much of it, it kind of collapses in on itself. It's kind of hard to visualize. That's just mechanical energy, kind of like when you rub, I don't know, if you rub something against steel or something like that, or you're rubbing your feet against the carpet, eventually you're going to get some sort of static charge, and that's how you're going to end up getting the ignition source for that. one second, I'm just trying to get this other one to kind of show in a smaller scale. And I think this one video actually really shows how the difference of having confinement versus having a situation where it shows a couple different explosions in a couple different environments. 1 second.
Alex, we did get a request for you to come back and do a Amos happy hour with us as well.
Yeah. That video does not seem to want to work, so I'll just kind of keep going on. But basically, what they show is in that other video it's going to show, they actually just had a bit of non-dairy creamer, that kind of fake coffee creamer that they put into coffee. And basically what happens, they put only about 4 ounces of it, so like this much about in there, and then lit it in a couple scenarios. In one, they just lit it on fire in a metal container that was open, and you just see a fire flash up, little fireball flash up, nothing, not too big of a deal. That's what typically happens in a dust explosion. In the second scenario, they close the lid and latch it shut. And because you have the expansion, it happens so quickly with that burning, it shot the lid off and shoots it about 30 feet into the air, which kind of goes to show you it doesn't take very much for you to have a lot of force generated from one of these explosions. Now here I'm going to look, now here I'm showing you right now on this screen. Abby, can you see the screen?
I can.
Okay, good. Here is Imperial Sugar in Wentworth, Georgia. They produce under a large variety of brands. You probably had sugar from them before. They do some stuff for Domino and stuff like that. Just to kind of give you an idea of scale, this is a huge plant. And this, as you can see, here's the cars in the top right. This is about the size of a house. This area that's circled here, this whole area pretty much went up in an explosion due to sugar. So basically, they poorly managed the dust in this location. And as you can see, and then they caught the dust, they enclosed the dust, it caught an ignition source, and then we ended up with a very, very large explosion because it propagated throughout this whole portion of the plant. Here's the before picture in 2008. Here's the after picture. As you can see here, this building, this whole part of the building is there in this picture. It's gone here. Those are 3 sugar silos right there. This is the transport system from the silos into one of the areas down here where you had a sugar conveyor belt. We'll go through the video and that'll kind of give you an idea in a bit to kind of show you how this happened, but just to kind of give you what conditions occurred. Again, this isn't your dad's wood shop. There was literally this buckled concrete, destroyed steel, and this caused a couple $2 billion in damage. See, it looks like a snowstorm hitting here. Basically, it's a huge amount of dust, sugar dust everywhere, powdered sugar, granulated sugar, all kinds of different sizes. And as you can see in this picture right here, it's very, very small. There you can kind of see up on these piping, everything like that. You have a bunch of it kind of piled up. And notice how the picture is cloudy. That's where particle size comes into play because it's all throughout the air there. So this whole area pretty much has a pretty explosive environment. That cloudiness, my company actually looked at this place back in 2007. They were there for about 20 minutes and just left because the people were kind of freaked out by it. And the thing is, it operated for decades without a problem before this loss occurred. But as you can see here, you could shovel this stuff.
So if you lit a match in that room, would it just explode?
This one right here?
Yeah.
The problem is you probably would have a minor explosion to start. And then what will probably happen is, see all this stuff. And this is where you usually see a loss happen. That's a really good question. You probably would have, if you put the dust in this room, you probably would have a flash. And then what would happen is there would be a bit of a shock. And then all the sugar from these upper areas would come down into the air, create an even larger environment for there to have an explosion. And then that secondary explosion probably would be what would damage this room. So yes, if you lit a match and you had a big enough ignition source, you could have an explosion occur in this room.
Wow. And we do have a question coming in from Dr. George Hurd. He said, what is the typical particle size? Is it on a nano or micro scale?
Micro. It depends. We see all kinds. It usually goes to micro. It doesn't have to be nanoscale. It doesn't have to be super, super tiny. I mean, we're looking literally at powdered sugar. So it's not quite on the side. You know, you're looking at wood dust too. So it's something that you could very, very easily see in a lot of scenarios. So it's not like we're looking at something ultra, ultra tiny. Hope that answers that.
And we have one more question from Ben coming in that says, what is the most dangerous at-risk situation you've dealt with working in your field? And which steps do you take to prevent or deal with the accidents? And how urgent are your work timelines?
My work timeline, typically when I go to a site like this, I have 5 calendar days, not business days, to get my report in to the account team. And we usually get our findings back to the client within 2 weeks. It has to go to the account side of my company. The most dangerous environment I've dealt with. That one's tough. So I deal with, this is only one of the hazards I deal with. I guess the scariest place I've been to was a peak shaving natural gas facility where they had a bit of an issue with one of their the vaporizers was leaking some natural gas into the air, but that was outside. Well, I just left. But yeah, it's basically, just to give you an idea of the peak shaving places. It's a facility and they're all over the place. You can see them from the highway. They have these gigantic tanks where they take natural gas and compress it into 1/60th its size as a liquid and store it in these gigantic concrete thermoses, I guess you could say. And by a thermos, I mean this thing is about 4 feet thick of insulation. And these things are often, the one I looked at yesterday, actually it was one of these places yesterday, had about 5 million gallons of natural gas in it. And basically what they do is there's a couple ways they get the natural gas in there. One of the ways is they'll pull it off of tanker trucks. The other way is they'll pull natural gas and its gaseous form off of a pipeline and then put it through a really, really powerful compressor using a variety of different techniques I know one of the 5 stages of compression that basically took this stuff, push it together and turn it into make it a liquid. And then they get around -280 or so, and then they pipe it in. And then after that, it's called a peak shaving facility because obviously in the winter time, you'll have times where there's a huge demand for natural gas and it's larger than what the natural gas companies can supply at a given point in time. So all summer, these peak shaving places are just condensing natural gas or just pumping it into this big container, 5 million gallons. And then they have another part of the plant that's just that's literally designed to safely expand it back into a usable form, back to natural gas you can use in your house. And that basically, the peak shaving is to deal with the demands that are way above what the natural gas company could supply at a given point in time. So it's usually in winter that they do it. It's like, basically you got a peak, they come out and it kind of cuts it off. There's a part above it that it can't be supplied by the gas company. And then this place kind of meets the demand between what the gas company can supply and what's needed, and for short periods of time. But at the end of the day, it's how you get a continuous supply of natural gas in the wintertime. And these are literally everywhere in the country. If you have gas, then you're definitely hooked up to one of these facilities. But yeah, the scariest probably was when they had a bit of a leak. I wasn't too freaked out because I just didn't go close to it. Basically, in the situations, my company is really good in the sense that if I don't feel safe, they just tell me to get out of there. So, and that's pretty much what I did. You got anything else right now, Abby?
Nope, not right yet.
Okay, I hope that helps. Let's see. So yeah, Imperial sugar. That was that one area. Let's go back to that picture. This area right here. is right here. There's the sugar silos, and here's the transport area from the sugar silos down to where some of the conveyors are. The explosion happened in this area down here, propagated up this tower, and then it caused a lot of damage to the surrounding area. And then here is, Abby, here's that first video I was going to have you show. Here's the chemical safety board video that basically shows the study that was done on this. And whenever you have a large explosion or any type of large loss like this, the chemical safety board has been around for about 40 years or so, is a board of basically a bunch of extremely experienced engineers that take a look at these large losses, and then they show what their findings are. So here's the specific hazard investigation that went for the Imperial sugar loss.
Can you hear it?
I can.
At 7:15 p.m. on February 7th, 2008, a series of violent sugar dust explosions devastated the Imperial sugar refinery in Port Wentworth, Georgia, just outside Savannah. Explosions raced through the buildings, fueled by accumulations of combustible sugar dust and sugar that had spilled from equipment. Thick concrete floors heaved up, and brick walls were blown into stairwells and work areas, blocking many exit routes. Fires spread rapidly. 8 workers died at the scene. 6 more died later at a regional burn center. Dozens of others were injured. The plant's massive sugar packing buildings were a total loss.
The accident at Imperial Sugar was the deadliest industrial dust explosion in the United States in decades. It highlights the extremely serious nature of combustible dust hazards.
There were significant accumulations of sugar dust and spilled granulated sugar on surfaces throughout this facility. Conditions were set for a catastrophic accident.
Imperial Sugar's sprawling Port Wentworth complex began operations in 1917 and grew to become one of the largest sugar refining and packaging facilities in the U.S. Granulated sugar from the refinery was stored in 3 100-foot-tall silos and then conveyed into packing buildings where it was packaged for distribution. Granulated sugar was also converted into specialty products, such as brown sugar and powdered sugar. Sugar was transported by a complex system of bucket elevators, screw conveyors, and conveyor belts. During this process, sugar spilled onto floors throughout the work area. In places, the spilled sugar was many inches deep. This sugar also contained fine particles, which became airborne. In addition, hammer mills were used to crush the granulated sugar into powdered sugar, creating even more dust. The machines were connected to a dust collection system, but it was undersized and in disrepair, and it was not connected to the bucket elevators and conveyors. Significant amounts of sugar dust escaped into the work areas. Workers routinely used compressed air to clean packaging machines, further dispersing sugar dust throughout the buildings. Over time, large amounts of dust accumulated on elevated, hard-to-clean surfaces, such as ducts, beams, and light fixtures. These surfaces were not cleaned often enough to always keep the dust below hazardous levels. In the tunnel beneath the sugar silos, granulated sugar flowed through chutes onto a long steel conveyor belt. From time to time, clumps of sugar would become stuck in one of the chutes, blocking the flow of sugar on the belt, spilling sugar onto the floor and releasing dust into the tunnel. But the tunnel was large and ventilated, so this airborne dust did not build up to explosive concentrations. However, in 2007, the company enclosed the conveyor belt with stainless steel panels to protect the sugar from possible contamination. The enclosure was not equipped with a dust collection system. As a consequence, sugar dust would now be trapped inside this enclosure. On February 7th, 2008, clumps of sugar were found blocking one of the discharge chutes. Sugar from the adjacent silo likely spilled off the moving belt. Dust likely accumulated to an explosive concentration inside the enclosure. At about 7:15 p.m., the sugar dust contacted a nearby ignition source, likely an overheated bearing, and exploded. This primary explosion blew apart the enclosure and into the packing building. Accumulated sugar was lofted and ignited by the advancing fireballs. The dust clouds fueled a chain reaction of secondary explosion, which swept through the building. Concrete floors buckled, releasing tons of granulated and powdered sugar into the flames. Emergency evacuation drills had not been conducted, and the explosions had cut the power to much of the interior lighting. In the maze of darkened and damaged stairwells and passageways, workers desperately tried to flee the growing inferno. The CSB found that correspondence dating back to the late 1950s showed that plant managers in Port Wentworth were aware of the explosive nature of sugar dust and the danger of dust accumulations. As far back as 1961, a memo described a sugar dust explosion that heavily damaged the powdered sugar mill room.
Despite the long-standing awareness of the explosive nature of sugar dust, not enough was done to manage the hazard.
In 2006, the CSB issued a study of combustible dust, which called on OSHA to establish a comprehensive combustible dust standard based on the current standards of the National Fire Protection Association, or NFPA. In October 2007, OSHA began implementing a new national emphasis program to increase the enforcement of existing regulations related to combustible dust.
Imperial Sugar learned of the OSHA Combustible Dust National Emphasis Program 4 months before the devastating explosion at Port Wentworth. But management did not act effectively to control the serious dust problem in the packing buildings.
Less than 2 months before the disaster, an internal inspection showed that many tons of sugar were still regularly spilling onto the floors. This provided much of the fuel for the massive secondary explosions and fires. The CSB found that over the years, the Port Wentworth facility periodically experienced small fires fueled by spilled sugar and accumulated dust on equipment, but none resulted in a sugar dust explosion that propagated through the plant. Investigators said that decades of operating without a catastrophic explosion may have lulled managers into complacency. In its report, the CSB issued the following recommendations to the Imperial Sugar Company. Apply NFPA standards to the design and operation of the rebuilt Port Wentworth facility. Develop and implement comprehensive combustible dust control, housekeeping, and training programs. Improve emergency evacuation policies and procedures.
Companies can go a long way to control combustible dust within their own facilities by following the existing recommendations of the National Fire Protection Association. But it is also time for a comprehensive federal standard on combustible dust.
In April 2009, OSHA announced plans to begin rulemaking on a combustible dust standard for general industry. In its final report on the Imperial Sugar accident, the CSB recommended that OSHA move forward expeditiously with the new standard.
Without regulation, enforcement, and education, workers will continue to be at risk from catastrophic dust explosions.
For further information, please visit csb.gov.
We're good. Good? All right, let me see. I'm going to share my screen again.
Mm-hmm.
Share screen. All right, so now we looked at that. The question now obviously is, how do we prevent this? And, you know, my job basically is to help prevent stuff like this from happening. Obviously, anytime I see an enclosure with dust at work, my thought is, how are we, you know, basically, where's the dust going? And is there any type of protection mechanism? And we'll go through that shortly. The two ways are mitigation and collection. Mitigation, simple housekeeping. That's when you have a relatively minor dust explosion. That's basically sweeping, vacuuming, hand vacs. And I know she showed in the video that guy blowing the dust off of machinery. There's ways to safely do that. Obviously, you don't want to just blow the particles into the air, but there are ways to, if you go from top bottom, that you can knock down the dust. So that's one way we started to see. That's relatively new. And this collection, there's specific pieces of equipment for, you know, dust collectors. Very, very creative name there. They're dust collectors. They collect dust and they basically make it so that they have a series of vacuums that basically pull the dust out of work environments and keep it so that they're down to below. The general standard is to have the dust below a 1/16 of an inch, which is the thickness of a coin, like quarter. And mitigation, which is something that, this is just housekeeping, that sometimes, depending on the situation, I'll recommend this if I see a bit of a dust exposure. You know, there's a little bit of stuff over 1/16 of an inch. It's kind of borderline, but they're pretty much managing it. I'll kind of say, hey, just sweep a little more or something like that. If they can keep it to within 4-hour shifts that they do it, then that's one way you can handle it. And a lot of times less expensive. One other way is to use techniques that produce less dust. One thing is, like, say you're cutting, a lot of cutting, like wood cutting operations will produce a lot of dust, but say you use a type of like a wet cutting fluid or something like that. Obviously, if the environment's kind of wet, you're not going to end up having dust go into the air. So that's one technique to produce less dust and prevent the dust from being kind of in the air in the first place. Abby, you got some questions?
Yeah, so Ben asks, since OSHA has released the emphasis on combustible dust management plans, has there been a downward trend in the accidents of this type?
There definitely has been. I know now there's a lot of places I go to. I've only seen one place where I felt uncomfortable. And they still had dust collection there. It wasn't near what the Imperial sugar situation looked like. And a lot of times there's some areas where they produce a lot of dust, or more often than not, I see it very, very well taken care of, properly sized collectors. I mean, honestly, if you are in violation of OSHA, then you're in deep trouble. So that's they can literally shut you down if they see something they don't like. So since this explosion, that's a great question. That's the reason I showed the video. Since that's happened, there's been an extreme amount of reform. And I guess I'm lucky that I started working with my company after that happened. But yeah, so now a lot of the stuff we see here, like I'm showing you right now, are ways that they are, a lot of times when I go to places, they have these in place. And a lot of times my job ends up being, are they doing it right? And what they talk about in the video is educating on what the hazards of dust explosions are and what the best way to prevent that from happening are. So that's one of the things where a lot of times people are trying to do the right thing. It's not, I know the CSB videos make it look like there was just mass negligence, but a lot of times people really are trying to do the right thing. Sometimes they just don't realize that they're creating a dangerous situation. That kind of brings me on to the next thing where I often see these things, dust collectors. These are often at sites. I look at these quite a bit. There's a lot of calculations I use to take a look to make sure they're properly sized. As you can see, these things are pretty big. This is actually, for this person there, kind of for scale. This one's actually not that large for a commercial dust collector. And this, you can see, kind of putting it in like a trash can sized type of thing. And note too, this is outside, which is a great place for it to be. A lot of times you have vacuum systems that collect dust into the dust collector. And then you need two other things to prevent damage to the facility and really to make it a safer facility for people, and that's explosion isolation and mitigation. As you can see here, there's this kind of big blue pipe coming in, and there's that kind of that metallic pipe kind of going out. So it's not showing this in this picture, but as part of the protection system, there should be isolation valves that happen so that if you have an explosion within this dust collector, it'll keep the explosion contained between this area and in that collector itself. And this big square thing right here it's bolted on is part of the explosion mitigation. That literally is just that explosion vent. That piece of that right there is designed to blow off. So if you have an explosion, that'll launch off preferably away from your building and away from everyone. And it's designed to be a weak point in the system so that the energy from the explosion has somewhere to go in a safe manner. So basically you isolate and blow that panel off and you're in good shape. Also, as you can see, location's huge. These things should be outside. You do not want a dust collector located within a building because, again, you're going to have an explosion in your building. You don't want an explosion in your building. Sometimes they are inside, and I have seen situations where they have the venting outside on the outside wall. That's also okay. I mean, it's not preferable, but it's better than just having a freestanding dust collector in the middle. You're not really doing anything if you have a freestanding collector sitting inside your facility. So location's huge. And like I mentioned with those vents, you make the explosion go where you want it to go. You basically, if you have a properly sized collector, they do explode sometimes, it just happens, but they're designed to do that. So you'll lose a vent. It's better to get a new vent than it is to have to replace lots of pieces of equipment. And they're designed literally to not deform this. They're designed to protect the dust collector, those vents. So if they're sized properly, and that's a pretty complicated equation that I have to deal with sometimes, then yeah, you're pretty much in good shape there. If it's isolated and mitigated, then you're in good shape. And if the dust collector sized properly, you'll prevent there from being a dust accumulation within the site. And sometimes I have some situations like they talked about in the CSB video where it's not sized properly, and then you have accumulation. Sometimes operations change, they increase production, stuff like that. So I have to go to these sites oftentimes on an annual basis because conditions change over a period of time, and we have to help them continue to manage that. Abby, you got some questions?
Yeah, so we were just wondering if, is there some sort of seasonal concern where it's like less humid in the winter, or like geographically, if you're in a less humid location, are you at a higher risk for this type of explosion just because there's less moisture in the air?
Yeah, actually moisture in the air does have something to do with it. Not to the point where in our engineer, it's nothing you could really engineer differently. Like for example, if I'm in Arizona versus Virginia, I'm not going to, though obviously Arizona is way more dry than Virginia. We're not going to, there's not enough, the moisture difference in the air is not enough for us to make a difference in the engineering. So we're still going to recommend the exact same things, but yes, moisture in the air does make a difference for a dust explosion. A more moist environment makes it less likely for there to be an explosion. And in some regards, kind of adding on to that point, one of the ways that some areas prevent a dust explosion from happening is they do put moisture into the environment to prevent the explosive atmosphere taking into effect. Because you have a lot of humidity, again, less likely to have an explosion. So that's a very good question. But yeah, collectors are basically the first line of defense. Keep things clean and put it into a collector, put the dust where you want it to go. And again, obviously, you don't want to under an enclosure where there's no protection. One other thing too is with those conveyors they were showing, I just kind of want to make a quick point there. They talk about, you might wonder where that ignition source is from, because it doesn't really seem, I also didn't really explain it too well. Sometimes when you have those conveyors, if they're not lubed properly, the bearings can get really hot. And then that's actually one of the largest sources, ignition sources for a dust explosion, because obviously you need moving parts to move the dust around. that bearing gets hot, that usually serves as ignition source in most dust explosions. And as you saw too, they didn't really show it too well, but those mini explosions they were talking about, those were all from bearings also. All right, so where do I come in? I make these recommendations, kind of like a lot of those NFPA recommendations they talk about. FM Global is the company I work for. There's kind of our little logo right there, FM approved. We do a lot of testing. I'm trained specifically to help. This is one of the hazards I'm trained to help prevent. I also do chemical plants and stuff like that. So, because I'm a chemical engineer, this is just one of the major hazards I deal with. And basically, I work for an insurance company, but they have me go into these places often once a year, and I make a series of recommendations based on what I see, and this is part of my evaluation. I say I see a situation where there's dust everywhere, I'll make it a recommendation saying improve housekeeping, or and if I don't think they can improve housekeeping to the point where they can keep their dust hazard under control, then I'll recommend they get collection. If they're fencing inside, recommendation will be, put the collector outside, something like that. I try to make practical recommendations to help companies not have losses. So that's the main point of my job. This is just one of the hazards I look at. I look at fire, flood, natural hazards, a bunch of other stuff too. But FM Global, one of the things too is, you might wonder, why would I make these recommendations? How do I know these things? My company's been around since the 1860s. We've been around for 140 years before that this Imperial explosion happened. We've been making those recommendations before it happened. We actually prospected that site to take a look at it to possibly insure it. And our engineers were out of there in about a half an hour because they were uncomfortable. So we actually saw this happening. And the reason we know this stuff, not only is to do with a large amount of experiential knowledge, but also we have our own testing facility to stay ahead of the curve. We literally have in Rhode Island a giant testing facility where a bunch of really, really smart people, PhDs and stuff like that, just light stuff on fire and blow it up, just to kind of see how it works and how we can stop things from blowing up and lighting on fire. Yeah, like I said before, we burn things and blow them up in controlled environments, obviously. So Abby got that second video. This is basically a video kind of demonstrating one of the hazards we look at. A lot of times we look at fires in warehousing, and this video is kind of directly from our testing facility. It's kind of made for the public, just to kind of show you some of what we do.
Fire protection codes and standards vary worldwide. Although your facilities may meet local codes, is that enough to ensure your business remains resilient? FM Global has over 100 years experience doing scientific research to prevent disasters at your facilities. You are about to see what could happen in a warehouse during a large-scale fire.
Yeah, those aren't fire protection hoses. Those are torches.
Between a facility that's well protected and one that's not. The storage on each side is identical, but only one is protected with a fire sprinkler. Watch how quickly the fire develops. A fire like this can shut down your facility and even disrupt your supply chain unless you're protected. The fire on the right is being controlled in under a minute, but the fire on the left grows more destructive. Such a fire could impact your market share, shareholder value, and corporate reputation. Few minutes have passed. The fire department won't arrive on average for another 8 minutes or longer. Notice on your left the amount of smoke. That fire will soon generate temperatures over 1,000 degrees Fahrenheit, 538 degrees Celsius, enough to weaken structural steel and collapse your building. The fire on the right is completely controlled. An investment in sprinkler protection is an investment in your business resilience. Fire destroyed most of the unprotected product. The product on the right suffers only minor damage. With adequate sprinkler protection, a fire may never make news headlines that create even more business damage. Because when you're resilient, you're in business.
Yeah, so that's one of the things that, let's see, am I sharing my screen right now?
No.
Okay, I'm gonna do that again. YouTube doesn't seem to want to be cooperating with me today. But the other video I had on there was basically one of a video we have. Actually, I've physically witnessed this where we have people sit across the field behind a barrier, like a glass barrier on the other side. They put a bunch of dust into an enclosed area and light it, and then you watch it go bang. And you kind of get to see that it's interesting when you actually see it and actually hear it. It's actually, it's a very, very quick event. There's no time to react to it. So that's all I have today. That's just one of the hazards I look at. If you have any questions, I can also talk about, if you guys are curious about some of the stuff I look at, or if you're curious about how a chemical engineer ended up in property insurance, I'm open for whatever here.
Do you have a favorite hazard to deal with?
I like handling, my favorite definitely are the chemical hazards. I'm a chemical engineer by design. It's actually this is in my company. They have everyone who is in my position as a consulting engineer has a degree in engineering. Not all of us are chemical engineers. Some are civil, some are mechanical, a lot of mechanical and civil actually. And we end up getting specialties. Some of them specialize, and these are more the civil and mechanical people might specialize in, wind. For example, we take a look at roofs and stuff like that, because in high wind areas, the roof could blow off. And they look at this, they become experts on wind, and we actually do uplift testing on roof builds. We have some people who are experts in flooding. They look at FEMA data, take a look at the finished floor elevations using GPS equipment to determine if a site could get flood exposed, especially considering how in recent years storms have been getting more and more severe. In my specific situation, because I'm a chemical engineer, mine is process safety. So, and dust, stuff like this. You end up seeing dust in a lot of chemical plants. But one of my favorite things is when I deal with reactors and other types of what we call ignitable liquids, which are, could be anything under the sun from diesel to liquefied plastic. It really depends. I kind of like the hazards that kind of are related to what I learned in school. A lot of times for chemical engineering, that involves a lot of, obviously I learned in chemical engineering, basically what we do is you have, they call it glorified plumbing in some regards, because you have, obviously in the laboratory, a chemist will find a way to make a product on a small scale. And then what we'll do is we'll take chemicals A and B and turn them into whatever you need the final product to be, but we find a way to do it on an industrial scale. So we have to really know a lot of the ins and outs of how both of them are going to react, how the reaction, the nature of that reaction, what byproducts are created, stuff like that. And in my job right now, how to safely perform that process. Process safety has been huge over the past about 40 years. And it's interesting, sometimes I go into plants, chemical plants. There's one I go to makes formaldehyde, which is embalming fluid. And that plant has been around since 1920. And there's some vessels there that are still in service, that have been in service since 1940. And it's interesting seeing when I go there versus the new plant, how different things are done now. How much more stringent we are now, which is good. The incidents are much lower than they used to be because of stuff like the Chemical Safety Board findings, OSHA really cracking down. And really, each incident that happens, we learn more and more. But my favorite overall is when I get to deal with stuff like dust and the high hazard stuff, reactors and all that type of fun stuff.
And when you deal with hazards from, I guess, like these factories, does your position deal with mostly, I'm guessing, the infrastructure behind it? So if you have like an older building, is that harder to update, I'm guessing, or harder to meet those new requirements than if you have a newer building?
To that point, it's always cheaper to get it right the first time. So one of the things we do is if a new building is being built, we have our clients send us the construction drawings, plans. I evaluate the process if it's a chemical plant. Like I know there's one place I looked at that was making roof board for insulation that you see in everyday roofs, and that involves a chemical process that I took a look at, and the way we were able to basically engineer out the hazards before the building was built because up to new standards, because we took a look at it beforehand, and it's much easier to do then. So to that point, it's a lot more expensive to retrofit. So for example, if the hazard's already there, say they had an inadequate dust collection system that's inside, it's a lot cheaper in the beginning to just install it outside than ask them to move it outside, because a lot of logistics, how do you get it out there? There's a lot of things like that. So in the end of the day, newer stuff is less expensive and easier to manipulate to get up this code than older things, definitely.
And as a biologist, I kind of wonder, I'm guessing you don't deal with this at all, but I'm assuming there are some respiratory issues that are associated with dust exposure as well. So are there any OSHA concerns connected to your job specifically that deal with any of that as well, or is it mostly just the building?
If I'm in a room where I'm breathing in dust, I'm going to leave that room. That just shouldn't be there. The OSHA concerns aren't necessarily have to do with the health problem. It has to. There's a much greater imminent danger of a dust explosion than there would be, say, long-term effects of inhaling dust. Like, for instance, obviously, I'm assuming you're wondering if there's like a thing kind of like with where they had the issues with asbestos, with mesothelioma and stuff like that. OSHA doesn't necessarily get concerned about that. I know you need to have certain permits if you're going to go into a dust area. You should be wearing a face mask, but in the end of the day, you really shouldn't ever have to enter an area with a lot of dust.
And then we can finish up by, I'm interested in hearing about if the responses to the chemical reactions are going to be similar to the response to the dust.
In terms of how the Chemical Safety Board looks at it?
Or I guess in terms of how you approach it.
I mean, it's a completely different kind of hazard. I mean, at FM Global, to kind of teach us to have a pretty methodical approach. I'm going to make recommendations depending on where the hazard is. And I break each plant up. I don't necessarily look at each individual tiny detail of the plant. I just look at where's the risk. So I guess the way I would take, I guess in some regards, obviously not all hazards are created equal. If you have a mild dust exposure, it's not nearly as big as if someone's storing gasoline in a room. But really, we end of the day, what we end up doing is we don't only just take a look at, is this hazard here? We also evaluate how bad is it? I have to put a money number on it. We insure them for a certain amount of money. So I have to create the loss scenario and say you have 1 drum of gasoline versus 7. Obviously, I'm going to paint a different picture if there's 1 versus 7 and put a different number on it. Same thing with dust. There's a very, very large number of variables that come into play there. But in the end of the day, the way my company operates is, the way I learn all this stuff is we have our engineering standards. that kind of help us guide us on how we develop those loss scenarios and identify where the pinch points are of where the risk is. And we have one standard for dust, and we have a separate standard for chemical reactions and for ignitable liquids. So I would follow the guidelines either way. So in some regards, I do kind of treat them similarly. It's just a matter of I need to learn different things to handle different hazards.
Yeah, awesome. Well, do you have any last minute thoughts for our viewers?
I mean, at the end of the day, this is kind of an unorthodox thing to get into for chemical engineering. A lot of times you'll see people go into stuff like refineries, so ExxonMobil, companies like that. You'll see a lot of chemical engineers there. Some of them go into pharmaceuticals, like GlaxoSmithKline, Merck. That's the chemical engineering is a pretty, a lot of people have, I know some people that are programmers because you do a lot of math. Chemical engineering is extremely math heavy engineering field. You know a lot about it's actually has very little chemistry in it. It's a lot of thermodynamics and a lot of controlling environments, you know, through heat exchangers and stuff like that, and a lot of mathematical modeling more than anything else. That's kind of what gives you the background to do all these types of things, but it gives you a pretty good diverse skill set to really set you up for getting into, you're not locked in. It's a nice type of field because you're not locked into one thing. You know, I didn't think going into chemical engineering that I was going to get into property insurance, but here I am. So
yeah, so I mean, that's great. That's a lot. There's a lot of opportunity. It just kind of depends which way it takes you. So Alex, thank you so much for spending your morning with us, and thank you everybody who is watching. We will be back next week.
Thank you so much.